Let me run you through the Kelvin-Helmholtz instability. So Kelvin-Helmholtz instability is it's become unstable because of the flow shear. So the setup is we have above x equal to 0, we have a positive u going with y direction, and then at the negative x we have a negative u negative u negative uy, and the we assume we not in the magnetized plasma, we impose incompressibility, and then we have a perturbed term that is periodic in terms of y and oscillating at the frequency of omega. So we take the first moment and then do the curl on both sides and impose incompressibility. So we, of course, we define the du dx as a prime. So we have this expression. We have x, y, and z, three directions, and then we could eliminate some unknowns and end up having this neat expressions. Basically, eliminate u, y, and u, z, and we use the condition of the u as function, big U as a function of x, and then of course we assume that the perturbed velocity is converging at infinity. Then we have this expression. Then we'll apply a boundary condition. We need to study the boundary condition on this. First, for our convenience, we're moving to the moving frame at v equals to big U. Then at the moving frame, the displacement c prime equals c minus ut, big ut, and d c prime dt. Then it will become only have this term. Then it is only oscillating. So we have negative I omega c prime equals ut. Ux, and then we have this expression c prime I ux over omega prime. Omega prime is a frequency at the moving frame. Due to the Doppler shift, this expression we plug this in here. We have this. We know that the displacement is continuous, and the no matter in which frame it is still continuous. So the displacement. So this quantity is continuous. Then we integrate this equation by part. After some algebra and cancellations, we have this expression. As you can see, this quantity resembles this part. So if this is continuous, then this should be 0, and then that means this has to be continuous. So from here, combine here this to this, we have this is continuous, which is this is continuous, and this is continuous. So those are the boundary condition applied to the thin layer above and below x equals 0. Then we have this expression. You can think this is amplitude, and you can imagine this is pretty much, you can think it as a Doppler shift. So this is at a negative u speed. So this go from a negative u speed to 0 speed, and then to plus u speed. That's basically the factor of the moving of the changing the frame. That's how I consider it. So this, and then then this, and then applying those both quantum conditions will give us this expression, which is most important. Omega equals plus minus IKU, big U. So since it's imaginary, then that means it's always unstable. And thus, if we have a shear like this in the magnetized plasma, ideal MHD, we will have unstable Kelvin-Helmholtz instability. And just by physical instinct, you will think if the plasma is magnetized, then the magnetic field could take part of the energy once starts oscillating. Then the magnetic field could be stabilizing for the Kelvin-Helmholtz instability.